Hey guys, welcome again to my channel Learn with Smita Maheshwari. Today I am here for the computer science guys and the people who are interested in databases like Oracle, PL SQL and SQL, these kind of. So today our session is on the databases and the relational databases and the components and all. So here we are starting our session with our contents and all. Here are our contents. Database. So again, here are our contents. The contents are database definition. What is database and all? Database components. What are the components? Database architecture, types of relations, and our frequently asked questions. So we are starting our database definitions. So what is data? So databases consists of two things. One is data plus base. But what is data? So data is like any raw fact or figure. If suppose someone says like 14 RAM 4000 and date. So what it represents? Is something informative in this? No. So if we will arrange this in tabular form, so in our file, so how it will be? 14 will be the SSN number associated with the name Ram, and what's its salary? It's 4000, and it's what is this date represents? It's date of joining. So this is the informative form. This is called the database. This is called our database. So again we are repeating here. Here is our data 14 RAM 4000 and this date, but it doesn't give any information. But if we will arrange this in our tabular form like its SSN number or any serial number or a name and salary and date of joining, so it will give the information of a person Ram whose SSN ID is 14, whose salary is 4000 and who has joined the organization on 12th of March. So this is the database. Database is not this. This is a one file of database. It's the one table. And if we will say the database, so we will understand in our next slide what is the database. So databases consists of the following contents. Following components. The components are that is database. It is collection of files. So collection of files, that means what this means, collection of files. We have database like school database. So in this we have so many departments, and that departments like education department or staff department and all. So all that table, all that will be in our tabular form. The information will be stored in tabular form, and that all tables that will come into one database. This is called the school database. So that is the collection of our file, collection of tables. So here we will see the definition how the bits are stored. A data item is made up of characters like data item RAM is made up of 3 characters R, A and M. So in our computer system, a character can be stored 1 or more bytes. A byte is made of bits, we know 1 byte equal to 8 bits. Usually there are 8 bits per byte, but bit stands for the binary digit. So we know what is bit. Bit consists of 0 and 1. This is magnetized and non-magnetized. It will go like that. So each bit have the value 0 or 1 like that. So again these tables have what is files have? Database files, these are tables. So again this table, this is file collection of records. What these tables have? These tables have the records, and in what form? So these tables have the records in the form of fields. Like I have told you the school database. Suppose we are taking the staff table in that. So there are the fields like the name of the person, same which we have seen in our previous slide. So that is called our database with database components. Now we'll move to the next slide. As I have told you, the files are in tabular form. So this is our table. This will give the definition of components. It will clear picture of the components. What are the components? So here the components are tables, consists of entities. So entities is our employee table. What is our entity? Entity is our employee table. So this is our entity code. This is a one file of our database and our employee from our employee records. And the attributes, that are the fields. What they say: employee number, employee name, employee age, employee designation, employee salary. Now, third one is the records. What is this records? The records are the data entry. We have seen that the data entry. Data entry is in how many employees are there and their employee number, their name, their age, their designation and their salary. So in that is the records. These are the records. So here are the other, but what this record says, how they are stored in our database. So they are interrelated. So how they are interrelated we will see in our next slide. Now first we will see how our file is storing in our system. How these are coming in that way. So this is our architecture. First is our this is the internal storage. This is our disk. In this the file will be stored. And then here is our physical view. And then conceptual view, then our external views. So how it will store we'll see with the example. That will be in our next slide. So how it is storing? So it is storing this is our disk. This is our internal storage. Yeah, this is our internal view. So how it is stored in our disk? It is storing like that. We have like bytes and offsets. Type of byte is 6 and these bytes are again consists of bytes. 6 byte means 1 byte equal to 8 bits, so we can calculate. So this employee number, it is this, and so this employee number, now it is type of byte is 6, so and offset and index, and this is index, and this is department number. It is again type of byte and offset is 12. Again type of byte, and in this kind of just file storing. In our internal view, it will store in the type of bits, offset and bytes. In that way it will store in our internal storage 0 in 1 format. It is like that. Now, and if we will come our conceptual view, what is our conceptual view? So an employee table is fields: employee number, employee name, age, designation. In department table has fields like department number, salary. So let's see in this our architecture. Here is our on conceptual view. All are at the same thing. All are at the same level. So at this level, employee number, department number, employee number, all are at the same. In the same way, we are seeing like that in our database. So we have the files like departments and employee tables and salary table and accounts and all that have in our one database. So it is all at one place. It is a database. So our employee database, employee record database. We can say it. So in our external view, how we can see. So in our external view, if we want the record of the employee, we will see our employee table. We will refer our employee record file. If we want the departments, so we'll take the department information from our department file. If we will see the accounts, so we'll use our account file. So this is our external views. External views all are distributed, means all are distinct. So in that way, we can view the records and all. And this is a storage. This is our database level, and this is our file level. How we are user level. At user level, how the files are storing. In that way, we can. So now we move towards our next slide. Once more, we'll go through a slide. Here is first is the internal view, that is in first is our internal view, that is in our 0-1 format, that is bits and bytes and offsets and all. So this is our internal view. We all know how our computer system stores the files. So always at the lower level, at the lowest level, always it is the byte and bits format. We all know about that. So here again at the conceptual view, what we have our database level. So here the database level, we have like all the tables in one file, that is our database, and schemas are there and the schema level. So in that way we will see our employee number, and in that way the employee table and department table, both it will be there. In that way at the conceptual all will be there at one place, but at the external view how we'll see, suppose if we want to if we want to see the records of the employees, so we'll see the employee file in that way the employee. If we want the information about departments, so we'll go on the department file. If we want the account, we'll go on account file. So in that way the external views are there. So here is the architecture. Now what are the types of relationships? As we have seen our database components, all of the all of the records are interrelated. So what kind of relationships it is related? We have the relationships like that. We'll move to our next slide. As we have seen a one-to-one relationship. So one-to-one relationship is what? So if there are two entities, person and passport, so a person is associated with one passport and a passport is associated with one person. So a person has ID, name, age and gender, and the passport is passport ID and passport number. So person ID is related to passport ID and passport ID is related to person. Here we cannot say like that one person is so many passports, or so many passports, or person can have so many passports. So here is only one-to-one relationship. Person has one passport and passport has one person in that case. Now one-to-many relationship or many-to-one relationship. So here we have the example of where one entity interacts with many other entity instances. Suppose we have the entities owner and pet. So owner is one for so many pets, but the pets have only one owner. In that case, we have one-to-many relationships. Now many-to-many, where many entities has many relationships, multiple entities of the other record set. So many teachers can have many students and many students can have many teachers. In that way, we have many teachers have so many subject departments. They are associated with so many departments, and so many departments associated to so many teachers. And that is we can give the example of many-to-many relationship. We have the best example of the relationship is our family tree. We will not go anywhere else. We'll move towards our family tree example. Okay. So in our next slide we'll see our family tree example. Now we go with our next slide. Here's our family tree example. Now I'll call Parishi for this. Hey, hi Parishi.
Hi ma'am.
Yeah.
Can you explain me this family tree in database?
Yeah, database relationships are same as our family relationship. Suppose you are my child. So I'm your mother and father. I'm your mother. So a child or the parents have one child or two child. That is from parent side one-to-many relationship. But child have one parents. So child have what relationship with parents? Many-to-one. This is one-to-many and many-to-one.
Oh.
Here again we will go to our next relationships. Like grandfather, grandmother has many. They can have many grandsons and many granddaughters, but they have only one grandparent, one grandparents. Now, here again we'll move towards our relationship like uncles, aunts, and nephews and nieces. So nephews and nieces have nephews and nieces. They have so many uncles and aunts, and so many uncles and aunts have so many nephews and nieces. So this is many to many relationships. In this way, our family tree works. You got it?
Yes, ma'am, I got it.
Okay. We'll move to our next slide. Here are the frequently asked questions. What kind of questions on these topics which we have done in our slides? What kind of questions they can ask in exams or an interview? Any. What is DBMS used for? As we have seen that for our record purpose in school, in offices and employees and all. This is all DBMS is used for. What our database means, as we have seen in our slides, data plus base. Describe the architecture of DB, how file is stored in memory, and what is called schema. Schema are the table level schemas. We have entities, schemas, and all. So here, the question 6, what are DB components? As we have seen in our slides. Define the relationships in databases, as we have seen. How many types of relationships define each? As we have seen. What does family tree mean? And what does family tree represents? Types of database languages. So we have PL SQL, SQL managers, and other DB languages. You can give the examples. So this is our things which we have done in our slides. Now we have, this is to do activity. Hi Parishi.
Yes, ma'am.
Can you do this activity for me?
Yes, make your own family tree and explore it. I will do it.
And this is for all other kids, this activity. So that was my session, first session on a relational database DB. So bye bye for now. Thanks for watching.
Okay, thank you, Smita. So I think we should go a recap for what we have learned today. We learned relational database in Oracle. So what we have learned is database definition, database components, database architecture, types of relation, and frequently asked questions in interviews or in exams. They have learned database definitions, what is database, how data works, with an example of a person with her salary, with his date of birth, right, Smita?
Yes.
Okay, so we have learned here how the database flows into the components. If you want to just speak something about it.
Yeah, database components are like that. Database is a collection of files are our entities and all, and these entities have the attributes and these attributes have the records, and these records are stored in the fields. So in that way our data flows or data has stored in our database with these components.
Okay, I think you explained it well. So what we have come to know, that only 0 and 1 can be stored into a memory in bits and bytes, and that is how database is also stored, but the representation of the data is a bit different when it comes to the user point of view. Okay, so what we have learned is here is an example of its tables, its attributes, records, and relationships. So what I can say, the database architecture we have learned here. There's a hard disk, it's a physical view, and it's conceptual view, and it's external view. So one of the example, you want to speak about it?
Yeah, we have this internal storage level, and we have then conceptual level, and we have then external user level. So how the internal view, as we have seen, how the file is stored, and at the conceptual view, how the database is designed, and at the external view, how it is, how the users can use.
A simple example, what I can say, if you go into a showroom, what we are keeping into go down, it's these things. what are the conceptual view, how we are managing it, and there's external view. So when we are going for some shopping, there's something we'll see into the showroom for the purchasing. So I can say like that. Okay, a good diagram of database management system. So a file it's stored in a computer, and you can see some example like some primary key, some logs, some cloud, some some file system and
OS, cloud server.
yeah. So these all are the part of the DBMS system. One of the example is how one-to-one relationship works, how one-to-many relationship works, how many-to-many relationship works. So get to know some good examples here, which are there.
We have something for kids. So we have introduced this a family tree.
Yeah, so I think a good example for your grandpa and your grandma. Only one grandpa and one grandma we have. They can have many childrens, many neighbors, nephews, and these things. So one-to-one, one-to-many, many-to-many.
Uncles and
Yeah, so I think
and
this,
father, grandpa, grandma.
yeah, this family tree explains each and everything. What we learn here. Okay, that's good. FAQs. So I think I don't need to go through all these things. It's we can just write
So
down.
you have to post the comment box for these FAQs. What you have learned from this session.
Oh, for the FAQs, I think we can post the answer into the comments and just give your
And this activity is for kids. Interesting.
interested in learning DBMS. Thank you. That makes sense. Bye bye.
Yeah, bye bye.